The nature of statistics. 14.5. Sampling. Sampling. A second branch of statistics is inferential statistics, which is concerned with making generalizations or predictions about a population based on a sample from that population. Sampling methods. A sample is a group of items chosen to represent a larger group. The larger group is called a population. Thus, the sample is a proper subset of the population. The population is considered for a statistical application is called the target population. The sample is analyzed, then based on this analysis, some conclusion about the entire population is made. Sampling necessarily involves some error because the sample and the population are not identical. A great deal of effort in statistics is devoted to the methodology of sampling. Here are some common sampling procedures. Simple random sampling. This sample is obtained in a way that allows every member of the targeted population to have the same chance of being chosen. This is the type of sampling we assumed so far. Systematic sampling. The sample is obtained by drawing every kth item on a list or production line. The first item is determined by using a random number. Cluster sampling. This procedure is applied on a geographical basis. The result is sometimes known as an area sample. Stratified sampling. The entire population is divided into parts called strata according to some factors such as gender, age, or income. When a population has varied characteristics, it is desirable to separate the population into homogeneous strata and then take a random sample from each strata. One of the concerns when conducting a sample is to decide the size of the sample. The size of the sample refers to the number of representatives included in the survey. The next example gives a formula often used in simple random sampling. Here we have n equals t squared, p times 1 minus p divided by m squared, where n is the sample size, t is the desired confidence level, p is the estimated prevalence of the variable of interest from 0 to 1, and m is the margin of error, usually less than 5%. In certain housing projects, it has been estimated that 25% of the children suffer from malnutrition. This number was taken from the National Statistics on Malnutrition in certain areas. What is the sample size of the desired confidence level for 95%? What is the sample size if the desired confidence level is 95% with a margin of error of plus or minus 3%? Solution. We set t equal to 0.95, p equal to 0.25, and m equal to 0.03. Because each of those percents are written in a decimal form. And then you plug through the equation. Obtaining the result of 188. So n equals 188. To choose the most appropriate procedure for selecting an unbiased sample from a target population, we must take into account two considerations. Is the procedure random, and does the procedure take into account the intended target population? A long-distance phone provider wants to sell new unlimited minutes plan and wishes to conduct a survey to find the degree of interest its customers have in such a plan. Which of the following methods would be most appropriate for obtaining an unbiased sample? A. Survey the current customers whose names are chosen from an alphabetical listing of all customers on the West Coast. B. Survey a random selection of customers whose names are chosen from an alphabetical listing of all customers. C. Survey the first 1,000 customers whose names are chosen from an alphabetical listing of all the customers. D. Survey the first 1,000 customers whose names are chosen from a list purchased from a competing phone company. E. Survey 1,000 persons whose names are chosen from the local telephone directory. The solution depends on identifying the target population. It is the current customers of the long distance phone company. So choices D and E are not appropriate because they do not reach the target population. And choice C hits the target population, but it's not sufficiently random. Choice A hits only part of the target population. Therefore, choice B is the most appropriate since it addresses the target population in a random manner. Inference procedure. Procedure for making statistical inferences. Step 1. Propose some hypothesis about a population. Step 2. Gather a sample from the population. Step 3. Analyze the data. Step 4. Accept or reject the hypothesis. Hypothesis testing. Suppose that you want to decide whether a certain coin is a fair coin. You decide to test the hypothesis. This is a fair coin by flipping the coin 100 times. This provides a sample. Suppose the result is heads 55 times and tails 45. Do you accept or reject that the null hypothesis is Do you accept or reject the null hypothesis that this is a fair coin? The expected number of heads is 50, but certainly a fair coin might well produce results obtained. Two types of errors are possible in any hypothesis testing situation. The two types of errors are type 1 and type 2. The type 1 error is rejecting a hypothesis when it's true, and the second type of error is accepting a hypothesis when it's false. How can we minimize the possibility of making either error? Let's carry out this example further and repeat the experiment of flipping the coin 100 times. Trial number 1, we got 55 heads. Trial 2, we got 52 heads. Trial 3, we got 54 heads, and on and on. If the coin is fair and we repeat the experiment a large number of times, it can be shown mathematically that the distribution of the number of heads should be normal, with the mean of 50 and the standard deviation of 5, as shown in figure 14.4. The question is whether to accept the unknown test coin as fair. Suppose that you are willing to accept the coin as fair only if the number of heads falls between 45 and 55. That is, within one standard deviation of the expected number. If you adopt this standard, you know you'll be correct 68% of the time if the coin is fair. How do you know? Look at the figure 14.46 and note that 34.1 of the results are within the first one standard deviation above the mean, and 34.1% are within one standard deviation below the mean. The total is 34.1 plus 34.1, which is 68.2. But a friend says, yes, you'll be correct 68% of the time, but you'll also be rejecting a lot of fair coins. You respond, but suppose that a coin really is a bad coin. It really favors heads with a mean number of heads of 60 and a standard deviation of 5. If I adopt the same standard of plus or minus 1 standard deviation, I'd be accepting all the coins in the shaded region of figure 14.47. So they're showing us the type 1 error is rejecting a hypothesis when it's true, and the type 2 error is accepting a hypothesis when it's false. So in one, we're centered at 50, we go down to 45 and up to 55, and in the other, we're centered at 60, we go down to 55 up to 65. Consider the hypothesis that the mean grade for a class is 75. We conduct a survey of 5 people from the class and find that their grades are 85, 65, 70, 52, and 96. There are 4 possibilities. We decided to reject the conclusion that the mean grade is 75, and A, the actual mean is 75, and B, the actual mean is not 75. We decided to accept the conclusion that the mean grade is 75, and C, the actual mean is 75, D, the actual mean is not 75. For each of the 4 possibilities, state whether the conclusion is true or which type of error has been made. So for A, we would reject a true conclusion, getting a type 1 error. B was correct, we reject a false. C was correct, we accept a true. And then D is accept a false conclusion. Okay, so C was reject a false conclusion, right? B was accept a true conclusion. So A, we had a type 1 error, we reject true. B, we accept true, so we're right. C, we reject false, so we're right. And D, we accept the false conclusion, so we're wrong, and that's the type 2 error. So your job on the homework will be to try to distinguish between the type 1 errors and the type 2 errors.